Okay, so today's day 7 and 8. We're just going to do some of the section today. And basically we have to put all the exponent laws together and solve problems where any one of these laws could be used at any time. We're just going to go through them one by one. The first one, anything to the power 1 will be itself. The next one, anything to the power 0 is just 1. And we've talked about that in previous lessons. This one right here, I'm going to make a little note on. Basically, the negative power reciprocates the base and that's all it does. That's the only thing it does. The negative power reciprocates the base. In brackets here, I'm just going to put a little note. Do not change the sign of the base. Okay, the negative in the exponent has nothing to do with the negative in the base. So if you change the exponents, you take a look at this. This was a negative 1, and now you have a positive 1. When you change the negative in the power, it has nothing to do with the negativity of the base. Okay, let's keep going. Here you have a product of two separate powers with the same base. You add those exponents. Here is a quotient of two separate powers, same base. Subtract the exponents. The next one is a power of a power. Okay, so you already have a power, and then you're going to raise it to another power. In that case, we multiply the exponents. All three of these should have been covered in junior high. Now these next two, these ones they look quite simple, but they're often screwed up by accident. So I'll show you, for example, this right here says this is a product, x times y to the power n. I'm showing you an example of that. So let's say you had like 5m squared. So what does that mean? That means you got to do 5m squared. So that means you have to repeat 5m twice. 5m times 5m is 25m squared. Or in other words, 5 squared m squared. Essentially, all you have to do, if you take a look at this one here, if you take a look at it, this power n goes on both. In our case, the 2 has to go on the 5 and the 2 has to go on the m. In my experience, I've seen a lot of students do this. They forget to square the 5. They forget to square the 5, so don't do that. So what we just talked about is the exact same for a division. Okay, make sure you put the square on both, or whatever power it is. So the next one is the negative exponent, which we talked about briefly up here. Basically, whatever this negative power is, you can just take it to the denominator and switch the sign. So we'll put a little note on that one as well. So negative powers are moved. If they're in the numerator and they're negative powers, you put them in the denominator and switch the sign. If they're in the denominator and they have a negative power, put them to the numerator and switch the sign. Okay, I'll say that one more time. If you have a negative power in the denominator, here's a negative power down here, just move it to the numerator and switch the sign to a positive. We prefer in math to have positive exponents, not negative exponents. If you have a negative power in the numerator, just move it to the denominator and switch the sign. Okay, and the last one we'll talk about is what happens if your power has a fraction. Now, if your power has a fraction, the denominator of the fraction goes to the index. So yeah, the denominator of the fraction becomes the index on the radical. And then the numerator, Vm, it can just stay there basically. It just stays as a power. Now you can put the power m directly on the base, or you can do what I typically do myself is I evaluate that radical first and then apply the m after. So for example, this one here, like I'll actually just use a number to show you. Like I'll choose one that makes sense. Because this is a 3 in the denominator, that means it's going to be a cube root. So let's just use a perfect cube like 8. Now, when you do this, you can do the cube root of 8 and then square it, or you can do the 8 squared first and then cube it. So that's your option. Now 8, for the number 8, you could go either way. Like the cube root of 8 is 2, and then you square it, you get 4. Or you can do the cube root of 8 squared, which is 64, and then the cube root of 64 is 4. So either way you look at it, it's 4, but the order that you do it in can change. Now, again, you can put 8 to the 2/3 in your calculator like this, and it will give you 4, but do you understand this process? And that's more important than just plugging away into your calculator. And the last note I'll make is a couple that you should just memorize. X to the 1/2 square root x, and x to the 1/3 cube root x. I would just memorize those ones because they're very, very common. Now we're not going to do all of these, obviously. That would just take forever. So we'll do a handful of them. And I would say for today's class we stop here. Yeah, and we can do this stuff on Monday when we get back. Okay, so go to section A. And we'll do some of these together. So here we have x to the 5, x2. That's going to be x to the 5 plus 2. This is x to the 7. Okay, this one is m7, m3 as a quotient. So this will be m7 minus 3, m to the 4. Those ones are junior high level, and those should be pretty straightforward. The next one is going to be power of a product, so a4 times b to the 4. Similarly, this one is a power of a quotient, that's x squared over y squared. Next one is power of two separate, or pardon me, product of two separate powers, so we're just going to add. Now, watch what I do here, just to stay organized. You know you have to add because you're multiplying. And then when you're adding integers, it's better to put brackets so you can see it's 5 plus a negative 2. So that's going to be 7 to the 3. Now, just another way that you can look at this is if you think about what we talked about on the previous slide, is like if you have a negative power, like that's 7 to the minus 2, you can write it as a positive power in the denominator. And then now you can see it's just 7 to the 5 minus 2, 7 to 3. You can see it's the exact same thing. So hopefully you start to understand what that negative power means. Next one, anything to the power 0 is 1. Oh yeah, so let's just give a quick highlight on F, G, and H, as they're all very similar. They're all 6 to the power 0, but with negatives placed in different spots. So for the first one, it's positive 6 to the power 0, which is 1. The next one is negative 6 to the power 0, and that's also 1, for the same reason as F is, as anything to the power 0 is 1. However, for H is all about bed math. You have to do the exponent before you multiply by the coefficient of negative 1. So it's negative, and then what's the answer to 6 to the power 0? Well, that's 1. And then negative 1 is negative 1. So that one's a bit of a trick. This is like, gotta be careful on this one. Alright, the next one is similar. You have to do your exponents before you multiply. So what's anything to the power 0? 1. 3 times 1, 3. Now I'm actually making pretty good time here, so I think we'll do all of these. Alright, 3 to the minus 2 is the exact same as 3 to the 2, but in the denominator. You just pick it up and move it from the top to the bottom and change the sign on the power. As well, if there's nothing left there, you can put a placeholder. This is a placeholder. And 1 over 3 squared is 1 over 9. I would urge you not to just pump that into your calculator to get 0.1111, because that has no meaning. The 1/9 makes a lot more sense. Okay, K looks quite challenging because of the negative there. And this one's tough. It's tough because there's no brackets, and you got to be really careful here. What this means, just like when we talked about the one above in H, like it's a bit of a trick. So what that means is like negative 1 times 4 to the negative 2. That's what a negative coefficient like that actually means. Negative 1 multiplied by this. So what I can do is put the 4 squared in the bottom and then evaluate that. So order of operations, exponent laws, these understandings really help in your learning of algebra. This one's a bit of a joke. I think we already did this one. Alright, keep going. Okay, again, we've already seen something similar with J and M. The negative power, like just pick it up and move it. So then you're going to have 4 to the 3 over a 1. The placeholder is now in the 1. You don't even need to write that. It's just 4 to the 3. It's just 64. 4 times 4 times 4. This one always gets the class. This is a tough one. So again, with your order of operations, BEDMAS, you have to do your exponents before you add. So this would be 1 over 3 squared plus 1 over 3 to the 1. Negative power, reciprocate the base. Evaluate those separately, 1 over 9 plus 1 over 3. Now to add fractions, you need a common denominator. That lowest common multiple is 9. Multiply top and bottom by 3 to get that. So you have 1/9 plus 3/9. This is 4/9. Well, that's a tough one. Got the exponent laws, order of operations, and then adding fractions. Everybody's favorite. This one's not too bad. Mostly just about understanding that you have like terms. What's nice is there's no exponents here. Well, there is. It's an exponent of 1, which you don't have to write. So that's nice about this. So really, those brackets, you don't even need those brackets. It's 2 times a times b to the 4 times 3 times a cubed times b times c. Those brackets there, you don't even really need them. All right, so the numbers go together. 2 times 3 is 6. The a's go together. Altogether, there's 4 of them. And the b's go together. Altogether, there's 5 of them. And there's 1c all by himself there. Alright, so again, similar, there's like a little separation in your mind between the coefficient and the power on x. I would leave the -7 on the numerator and take the x to the bottom, because that power -2 is only on the x. The -7 is in the numerator. The x to the -2 is in the numerator. But I want to get rid of that negative power. See now this positive power? So that means that whole term needs to get moved to the bottom. And that's done. This is as simple as it gets. I mean, you could put the negative off to the side if you wanted, but that's it. Alright, this one is similar to the one we did up here. Letter O and Q are very similar. So instead of multiplying here, we're dividing. So 16 divided by -4, that's an easy one. A positive divided by a negative is negative, so the coefficient is -4. You could put a placeholder of 1 if you wanted. The next one is A6 and A6. They're the same. You probably know that if you have anything on top or anything on the bottom that's exactly the same, you can just cancel. You can also use the rule, like 6 take away 6. And we'll use that rule. And for B, what would the B be? You'd have to go -3, subtract a +3. Okay? -3 subtract -3, that's just -6. So when you use the subtraction rule for the division, you get -6. I want you to think about that for a sec. Basically, you have a -3 power on the b in the numerator, if you were to pick that up and move it to the denominator, you would switch the sign, and then you have altogether 6b, b to the power 6, you have 6 b's in the denominator, which is exactly what this one says. I'm going to finish this off. Negative 4, a to the 0, that's just 1. Like we said, they are just going to cancel. And then b to the 6. Okay, so that's very messy, so I'm going to clean it all up and do it all over again. Okay, 16 divided by negative 4. The a's cancel. And then off to the side, negative 3, subtract 3. That's b to the negative 6. If I have b to the negative 6, that would be in the numerator after I do that rule. So then I can just slide it to the bottom with a positive. That's what you want. Again, so if you use this rule where you subtract the powers, the result ends up in the numerator. Alright, now the next one has us in the situation where we have this thing in a bracket raised to the power. So BEDMAS, order of operations, says you have to do those brackets first. So let's do that. 5 to the minus 2, p to the minus 2, 5q4. Now for this one, I'm going to slide a little 1 here to help on that 5 down there. So when I do the rule, negative 2 is the power in the top. I'm going to subtract the power in the bottom, which is a positive 1. The p to the minus 2, I'm just going to leave that. Then q to the 4. So that's going to be 5 to the minus 3, p to the minus 2 over q to the 4. And you look at the numerator there, they both have negative power. So I'm going to pick those up and move them to the bottom, leaving only a placeholder in the top. 5 cubed p squared q4. Evaluate the 5 cubed as 5 times 5 times 5. P squared q4. Final answer. Yikes. Alright, so we're looking at about 20 minutes here, so I'll finish off part B, and then that's it, and then you guys can work on your homework. So this is power of a power. Negative 2 times 4 is negative 8. Negative power is better served in the denominator. Alright, let's take a look at B. With question B, you have some nested brackets, kind of like those Russian dolls, like a doll within a doll. So you have a bracket within a bracket. It's like Inception, a dream within a dream. So my recommendation most of the time is to clean up the inside. You don't always have to do that. You could do power of a power like this, but I'm just going to clean up that inside first. So they have the same base, so I can add those powers. Two to the 0 is basically 1, so you're timesing by 1, which won't change you. So you essentially are just the same. 2 to the minus 2. And then you still have that negative 2 on the outside. Now it's power of a power. Negative 2 makes positive 4. 2 times 2 times 2 times 2, 16. Yeah, this next one, I would do the same thing. I would just clean up that inside. That's going to be 3 to the 3 minus 5. Okay, so 3 to the 3 minus 5 is going to be 3 to the negative 2. Clean up that inside, raise to a power negative 2. Power of a power, 3 to the 4. 3 times 3 times 3 times 3, 81. Alright, so there's nothing to clean up on the inside here because A and B are different terms. So you're just going to have to apply the power of a power first. The one big thing here is like you have a negative 1 being raised to the power 4. That's a very common mistake. Students will forget that one all the time. So 2 times 4 is 8, 3 times 4 is 12. Those are probably going to be done correctly by most of you. But this negative 1 to the power 4 is going to throw some of you for a loop. Okay, negative 1 times negative 1 times negative 1 times negative 1. It's an even amount of multiplications by negative 1, so that's going to come out as positive 1. So it's just a to the 8, b to the 12. A lot of students will leave the negative on the outside and get that one done incorrectly. That one's tough. Now you have something similar on the next problem with the power 3 and this negative 4. That's going to come out negative because it's negative times a negative times a negative. An odd number of negatives will come out negative. Then you have a to the 6, b to the 9. There's a power 1 over here, so it's like that bracket doesn't even matter. 8, a, b, 8. Let's just take care of these a's. That's 7 of them. That's easy. 9 and 8 makes 17 of those b's. That's easy. Now you got to put together the coefficient. These guys and this guy. So negative 4, negative 4, negative 4 is negative 64. And negative 64 times 8. I need a calculator. Negative 64 times 8, 512. And it's negative. Okay, so that's it for the lesson. What you guys can do is flip to the assignment, and you could probably just get started on the beginning of the assignment, and we'll finish the rest of this off on Monday.